Welcome to DOS Phone Hunt. I'm Xiao Pierre Ruth for Information Week. And in this episode, we are taking a look at, we're calling strange data centers in a strange land, data hubs in exotic places. We've been seeing a few examples of data centers being located in some undersea, now in outer space, some in orbits, some going directly to the moon. Well, it raises questions for, what does this actually mean for organizations and their CIOs and their CTOs and CISOs? You're relying on data centers to power your operations for your organizations, but then potentially, hey, the providers might be like, you know what, I'm going to locate this data center way out, very far of left field. Is this more of a novelty? Is this a way of looking forward, future forward of where data centers could be potentially located? So to answer this question, we are joined today by Dmitry Zakharchenko, Chief Software Officer with Blaize, Alvin Nguyen, Senior Analyst with Forrester, and we're also joined by my good friend Shane Snider, Senior Writer with InformationWeek, also a fellow member of what we lovingly call Squirrel Team 6 in our office. So all of you, thank you so much for being here today.
Thank you.
Thanks. Pleasure. All right, Alvin, let's kick things off. Does it raise concerns about the reliability if data centers that the organizations need are potentially in hard to reach locations? It could be undersea, it could be in space, it could be in the asteroid fields, beyond Jupiter, places that technicians cannot access immediately, if there's an issue that actually requires some kind of hands-on service.
Yes, it does. And not just with the reliability of the data center itself, but with the infrastructure, on Earth, roads, power, water, and connectivity needed to get to the remote locations. There's obvious ways to deal with the reliability. You can increase redundancy, like having multiple data centers, redundant assets, hot swappable assets with robotics, things like that. But essentially, you need to architect solutions to minimize the hands-on service or even eliminate it. But this all comes at an increased cost.
Gotcha. Thanks so much for your thoughts on that. All right. Dmitry, what are the potential benefits for exploring remote and these kind of like non-traditional sites for data centers? Is it the idea of the access to, more natural cooling, keeping data centers kind of like outside the public eye, so that's not like, oh my gosh, we have these data centers like in places that people might, get them away from the spaces. What are some of the potential benefits that are being explored?
Oh, thank you. Yeah, I feel like there is quite a bit that's happening at the moment. I mean, the need obviously for low latency, instant reliable compute is kind of fundamental, already presented itself to the industries, but we're seeing the underwater, we're seeing Arctic, we're seeing orbital. That enables being closer to the data, that enables taking the natural cooling, energy efficiency, security. There is no doubt that this is all well explained and understood. Being able to harness solar, wind, these are all examples of the things already happening. But what's really interesting, extreme location data centers are going through a major shift. When you really think about it, what's happening right now with the data and processing, which is what data centers do. In my perspective, the very interesting trend that I'm seeing and forecasting is that we're actually moving into a very strange location for a data center. I call it wearable, personal, hyper-customized data centers. That is something that is a very interesting way of looking at where is the data going to be. The data centers are just not going to be necessarily remote. The data center is actually going to be on you, with you, and quote unquote, just in time following you. And that's actually a result of both the hardware and software are getting smaller and smaller to the point where you can actually pack that information and take it on a journey with you. Why is it happening? Because in we need to understand that this decision making is kind of the next frontier for the AI. If AI before was more like an auxiliary technology, now we're actually getting closer to AI becoming a decision making, I guess, enabler, or in many cases it will be the decision maker as well. If you take certain industries, that shift already occurred. It's already happening real time. But when you get to the real decision-making exercises, the need to recall data from the massive centralized locations may not be sufficient and may not necessarily be even possible. So being able to be grounded in a real-time contextualized data that is basically near zero latency, that's what the decision systems are about. Because especially in the situations when the system needs to reason by similarities, you need to get to access to the information that's relevant for the moment. Kind of being just in time, in my opinion, is one of those exercises that this new location that is with you is equally as important. So when we think about the far edge and the close edge, I kind of see that the far edge exercises that the companies are going through right now by putting it underwater, putting it on the moon. It's about getting closer to the data. And the data is obviously everywhere. But I think the interesting part of that is, as we just discussed, is that how do you service, how do you protect it? And to me, what's becoming more apparent as well is that there is an added benefit of actually locating data in this distributed, highly distributed, decentralized way, because that kind of eliminates the single point of failure. It actually enables the data to be, quote unquote, managed in the individual segments and chunks, as well as the models and apps to be managed in the same way. I feel like this is the way to rethink what it means. Is the data center really now even a thing that we can describe a massive pool of compute and storage that sits in a certain location? Or is it really a very fluid, dynamic organization of data and compute that actually scales based on the need or a specifically it's in your pocket? It could be in the back of your vehicle. Like in a defense or healthcare applications, it's especially more obvious because the decision making needs to be nearly instantaneous, and being able to make that, especially in defense, that's almost becoming where each of the soldiers become essentially a carrier of a data center with them, if we think about it. So that's another way to think about a strange place for the data center to reside, is on a human or with a human. So just another perspective that I was wanted to share.
Gotcha. Appreciate their insights. Thank you for that. Shane, my fellow member of Squirrel Team 6 Squirrels on the Tracksuit Information Week. You've been working on a story looking at, I believe it's Red Hat. They've been doing some work that's also taking data centers to the stars. Can you tell us a little bit about what you're working on that's coming up for the story that you've got rolling out for this?
Sure. It's going to be a general profile with Red Hat's new CIO, Marco Bill, and we're going to have the news hook of their collaboration with Axiom to put a data center on the International Space Station in the spring. So we talked a little bit about, why Red Hat was interested in, putting their technology into this project. Without giving too much away, it's an interesting way for this technology to go, and I'm interested to see what advancements could possibly come out of it.
Gotcha. Well, definitely looking forward to reading that story. Awesome, great, and all of you, thank you so much for making the time today. Okay, so all right, let's get into some more of the thoughts about all of this, but potentials and the novelty versus actual steps forward for locating data centers. What kind of safeguards or guarantees would or should CIOs, CTOs, CISOs, kind of really want regarding the kind of like that reliability and security for such remote data centers? Not necessarily just the ones undersea or up in the stars. Putting things further out there, wherever they might be located. This topic of would failover backups and traditional locations be essential? It's like, okay, that's cute that you have a data center that's floating towards Mercury. I'd like to have a backup that is that going to be kind of like part and parcel to some of these efforts, do you think? That's open for anybody to chime in.
I'm happy to take a first stab. The thinking that we are operating under, like from the day one when I started a few years back at Blaize, one of the things that was very obvious is that there is a need for the models to quote unquote take care of themselves, right? Being able to actually self-heal. It was one of the fundamental things that that I'm seeing. And I guess as a strategy that's been pursued by Blaize. And one of the things that is actually continuously enabled is that when the models start to drift, data starts to drift, and that needs to be detected early. That needs to be addressed. And in a lot of the cases, that needs to be done by the system itself. That's why when you really talk about AI, it's not enough to talk about the data center where it's located. It's actually what's running in a data center. Is the workload prepared to actually reside in those data centers? And that's fundamentally where the thinking needs to start crossing that chasm between the data center is just a massive amount of compute versus the applications becoming and platforms becoming intelligent enough to take care of that remote, right? I think it's an effort on both ways for the CIOs to obviously prepare the data centers for that, but more importantly for the application developers and actually take that very active position. Can you actually design the application to detect that and take care of that? Because the self-healing used to be a dream. When many years back when I was at Intel, we discussed that, and it felt like, well, we're dreamers. We're talking about something that's not achievable. Now self-healing is actually a thing of real daily operations. Some of the smaller data centers that for example, I was actually chosen to run for the healthcare. I have to. There is no choice. There is nobody to be sent in the field hospitals to fix that issue because it's in the middle of a disconnected environment. When it's running, it's almost in an air-gapped environment. How do you take care of that if there are no technicians on staff? So that's a good example where data centers and application developers need to become much more of a holistic organism that thinks together. That's just one perspective on that.
Appreciate your thoughts on that. Alvin, any insight from you?
Yeah, I think one of the things here is that from an organizational standpoint, you evaluate it just like anything else. There's going to be trade-offs in terms of if you've got this remote location or unusual location with specific capabilities, you still need to know, your service levels that you have to achieve, your RTOs, your RPOs, whether or not you back up to a normal data center to a cloud, or whether you keep it there. So Dmitry has mentioned with self-healing, that's great, but that's just one component. If you lose connectivity, let the system still work. You still have to address what it means until you restore connectivity. So I think you still have to look at things holistically, both with normal as well as your unusual data center locations.
All right, appreciate both your thoughts on that. With the examples that we've been seeing so far, be it from Microsoft, Lone Star on the Moon, Axiom, and Red Hat, are we seeing what we're seeing now? Are these still just really experimental novelties for the moment, or is there any kind of sense that hey, there's some kind of long-term interest and push to really kind of start moving into maybe not these specific frontiers, but this is kind of one of the routes that data centers might start taking?
I can take an initial step. I think it's experimentation now, but if we are going to follow what Dmitry has mentioned about, hey, you're carrying the data centers yourself, it is a good experiment, a good step along the way towards that. It's not, the data center isn't going to be just a physical site in one place, but having physical data centers all along the way can help with extending that the concept of the user experience with applications in any location. And so I think these pushes, if we're really going to put a base on the moon, we have to have that experimental data center over there to figure out what challenges there are, how to address them. Same thing as in outer space, same thing in terms of the sea. If we're going to have more exploration, we need more sites. So there may be experiments now, but I think they're good experiments that will help us solve the longer term challenges.
And just to add to what Ellen was saying, in my opinion, what it really does, it actually challenges the engineering community to go and enumerate all possible scenarios that otherwise would be hypothetical modeling, right? Now we're actually kind of living through that. And as humans learn empirically, we actually discover more than we can ever potentially simulate in the best of the best simulators. It's still, when you put something is underwater, the amount of unpredictable that's going to occur to that is just tremendously more than any model can today potentially probably create for us. I think this is an absolute must. It challenges the engineering community to test the boundaries of like you said, of what's the art of possible and impossible. I think that's, to me, more it's a necessary thing. Whether they will actually indeed reside there permanently, that's a question to be seen. But the amount of learning that we're going to gain from that, to me, that alone is worth all these massive undertakings that the companies are doing. And to be honest, everything from radiation to the hardware that's happening in open space. We had an interesting episode when one of our chips actually flown on one of the recent flights to the space. We just did it because we had to actually be compliant. And you actually realize that you have to consider many more things that otherwise you wouldn't be even thinking about. Suddenly that's front and center. You cannot just take a piece of silicon with you. You actually have to make sure that silicon can withstand what it's actually going to be seeing up in the space. So that will push boundaries of that, in my opinion. So that's a necessary. But we will see what else is humans going to uncover. Arctic is certainly another very interesting thing for me. For the question is, what is it going to do when you put something deep into the ice? There is all kinds of work that humans been doing for the past 50 years there. How much of that is actually could be now actively challenged? Can you actually even physically run the cables? That's a very interesting part, right? That people don't realize how much infrastructure is dependent on very simple old utilities. That's, in my opinion, is even more challenging. Utility work is actually one of the most challenging things that as complex or as difficult as some of the machine learning problems that humans are trying to solve.
And speaking of the challenges, kind of like loop into the potential pushback, if there even has been some already, regarding our environmental side of things, safety questions, although these are still early days, early steps that they're being taken right now. Has there what kind of consideration, at least thought, may need to come into play with the idea of putting hardware under the sea? We already have satellites. That's not necessarily new, but the idea of just kind of like adding to the clutter of space even more. Are these things that are major concerns in terms of challenges and potential pushback, or not so much at this stage right now in terms of exploring these ideas?
I think it's to what was said before. I think it's the important thing is it's going to surface up new challenges. So in space, as you mentioned, the clutter, space debris, the fact that there are things there that can damage the satellites, solar flares, and those types of electromagnetic storms up in the upper atmosphere, those are all going to impact. And so how do we deal with that? How do we protect our investments up there are going to be important. And same thing with undersea or in environments that are very sensitive to changes, right? If you're having something dump a lot of heat, how does it impact everything in the environment? So I think the important thing about these is there are going to be, when you deploy and you experiment, there are going to be things you learn, things you have to adjust to. And it's part of the process. We'll have to find a way to address those answers. Maybe the answer is no, we can't place a data center there, or we have to remove. But that's part of the experiment, and that's part of the learning process.
Absolutely, and I think the need for rethinking the ensembles of the data centers is also very important. We need to make sure that, like Alvin was saying, if something gets stormed out of operations, what's going to happen? How do you actually? The concept of the duplicate is what I think we need to rethink as well, because that redundancy has a very different meaning in a new world, right? That redundancy means that we may need to have something that can potentially restore the operation of that item in space, that data center in space, but it needs to be in space itself. So it's not enough to have something, for example, on Earth and be saying that this is good enough for us, that we have a link back to that data center up in the skies. We need to actually have a parallel system that can, quote unquote, take care of the just failed one that's already floating up in the outer space. So there is just a very different way of thinking about it, and I don't think that we can just read about it. It's something that we need to understand what exactly the timings, the potentially the amount of communication bandwidth that needs to be available. That's something that I think you can only discover by actually dealing with it on a regular basis. That's a massive shift that we as humankind, I think, is testing, and I'm extremely excited to see that type of testing being even possible. It's expensive, and but it's well worth for the future of human beings, I think, to get to that really advanced cases. Yes, go ahead, Shane. Yeah.
When you think about some of the advancements that happened from our early NASA missions, some of the advancements in microelectronics, and I know our MRI and CAT scan capabilities came from space imaging techniques. So can we expect to see some advancements, hopefully, from some of these projects that can be used in traditional settings and data centers that maybe aren't heading towards Mars?
If I may, I just start, Alvin, and then I'll let you go in. In my opinion, we will rethink the concept of autonomous because of those missions. Because the autonomous we know today is just our human definition of what's possible. I think with the latency, with the disconnect that those systems going to see, it will force us to actually enable these devices to be pretty much decision-making capable. You have to actually enable them to be just from the helping device to become a decision-making device, or decision-making appliance, or decision-making system, or even platform, depending on what it is. I think that's an excellent question, Shane. I think it's gonna completely force us to take a very different look at what autonomous means, in my opinion. Alvin, to you.
And yeah, thank you. Well put. And it's not just that in terms of communication, but power as well. It's I think that's going to open up a lot in terms of once we're able to apply it for something that goes into space or goes into undersea, that's that remote. It'll change what it means for reliability and resiliency in our common technology. Obviously, with extreme locations, there's going to be a cost, but once we can find a way to commoditize that, I think it's going to open up quite a bit for what we see in infrastructure in our data center facilities.
And Shane, a quick question for you. Just with, again, not giving away too much of your story, but what was the kind of like the vibe or sentiment for the folks at Red Hat? Like this is ostensibly a newer frontier for them to like kind of get into. Was it just kind of like okay, kind of like fingers crossed? How was it kind of like that vibe of like, hey, we're trying this, we're going to give it a go?
Yeah, I think they look at it as an opportunity to be on the forefront of a new frontier in general, and they want to be on those. They want to be involved in the innovations that are going on, and they want to be able to give new solutions to new problems, I think. And, obviously it's, probably pretty good marketing too. it's a fun idea, fun project. I'm sure there are myriad of reasons.
And to be honest, it's what Alvin said is actually very important, because the power is what has been in some ways enabling, but also inhibiting the growth of these advanced technologies, right? And that's why the things that for example, that was our very much our determination, our strategies to figure out. When Blaize started, the whole thing was, how do I do it in the most efficient power package that I can potentially get? And a lot of the companies are just now starting to see the need to obviously reduce the power consumption. For some companies, it's going to present a massive challenge to reduce the power to the point where you send something out into the Arctic Circle. Like you said, you can send the team to, for example, replace the backup power, and you need to be able to run for months, if not long months, with no interruption from any of the human or intervention from the humans. So the device needs to be extremely frugal with the power consumption. And I feel like if you look into the chips that the companies are making, more and more, we see the chips that are actually moving to the distributed edge. And these chips have to be extremely low power, to the point where you have to operating in a single watts. When the Blaize chip came out, people were looking at us strange. Why you would even come up with a chip so small in terms of the power wattage? How can you actually do a performance on that? But it ended up, because everybody was looking at the GPU, but now it becomes an aha moment for a lot of the companies. They're saying, oh, now I see. Inference, if you look at the data, right, the data says, and Alvin probably has a much better data, but the data point I saw is that training to inference ratio is now between 1:5 and 1:4, meaning that for every one training workload, there is 4 or 5 inference workloads. They don't require the massive amount of power, but they require a very, very efficient compute that can actually happen. And I think that's another shift that enables these data centers to be in those remote spaces, because now there are chips and workloads that actually fit into those remote applications. They're small and lean, but nevertheless, they're performant. They actually deliver the value. If you look into the evolution of the language models that we've been seeing, from something that was powered by basically entire city or a nuclear power plant, now we have models that actually run on a single of our GSP chips that is only a few watts strong, and we can actually deliver almost the same results. That gives us enough evidence from the company that lives it every day that it's possible. So again, I think the power is a very important component of what Alvin mentioned. I agree with that.
Great. Awesome. Great. And one last question, kind of round things up for all of you to kind of weigh in on. Are there other types of locations, other environs where, Dmitry, you brought up Antarctica, putting things, whether or not it's conducive to put it, down in the ice. But, are there other locations that we haven't, explored yet, even with space and undersea, other types of places that could be beneficial for data centers to be located in that have not been, that maybe haven't been kind of really sorted out yet? Yeah. Kooky idea about thinking of the question I sent you all, like the idea of what if data centers were located, in or near a desert, so they could capture their own significant amount of solar energy. And actually, I just finished watching a science fiction series the other night where I'm not going to name it because I don't want to give out spoilers, but the character ended up using a micro star for a Dyson shell to then power this, can't even describe how much data processing that they were trying to do with their data set, the data nodes that they were doing. But that kind of idea, are there other frontiers that data centers could potentially be put in that would be really conducive to what we need them to do?
I guess I can start. Yes, and I think part of the things if you're going and using like hydroelectric, if you're placing it near the ocean, and wave energy, or thermal, or all these others, there are different environments that give opportunities in some cases for different energy sources, more renewable or more sustainable energy sources that can help out in terms of that. Now, like, we talk about the Arctic. I don't think we're going to necessarily put nuclear power plants there right away, but I think if we take a look at some of the other environments, if we can supply or supplement the energy, we can get more renewable sources, cheaper sources that will help kind of expand where we have access to data, where people can be located. So I think that's going to be important. The other aspect of it is that, again, like I mentioned before, the ability to experiment, not looking at everything the same way, but having some asymmetry in terms of power, reliability. It gives us a lot more flexibility, and definitely looking forward to kind of the innovation that can come out from there.
That's tremendously important what Alvin just been saying. But being a software person myself, most of my life we were looking at the things that we can do in code that actually brings the efficiency. So as many companies are trying to improve and find new sources of energy, the philosophical stance that I'd like to take is that my job is to minimize the amount of energy that we need in order to actually complete the same amount of compute that we do today. If we can reduce it by a factor of 2, 3, 4, we're essentially kind of bringing down the need for the power. Or you can take a look and we kind of just enriching the compute for the same amount of power that we otherwise are getting. So I think it's a two-way that needs to happen here. There is absolutely innovation that's coming out from the companies that can do it, but equal amount of innovation should be happening on the software and AI ML development side, which is we're already seeing evidence that's happening, right? But I think we're just about to see the new emergence of new architectures that's going to come into AI ML space that will significantly further reduce the need for power. And I think that will be more of a golden age of AI, when it's going to be lean, running in your pocket without overheating your devices, and it's going to be potentially what I call the ambient omnipresent. You will interact with AI in a very different way. Is this a dream? Yes, it's a dream, but the conversation that we're having today was a dream back 10 years ago, and we're having this conversation now. So I think it's possible. I'm super excited.
I'm kind of excited to see whether or not we end up with data centers located on wind farms at some point in the future. If that's not right, it's kind of cyberpunk thing happening at some point. Okay, great. Well, so Alvin, Dmitry, Shane, of course, my good friend. Thank you all for being on the show today. I really appreciate your time.
Thank you. Thank you for inviting. Yeah, look forward.
You can find the DOS Won't Hunt podcast on Podbean, Spotify, and other popular podcast platforms.